In question 2, it's given the probability x1 equals to 0 is 0.2. The probability x1 equals to 1 is 0.8. And for all k bigger or equal to 1 and smaller than or equal to n, there is a probability when xk equals to 0, sk plus 1 equals to 0 is 0.3, and when xk equals to 0, the probability of xk plus 1 equals to 1 is 0.4. And when xk equals to 1, the probability sk plus 1 equals to 0 is 0.3. And when sk equals to 1, the probability sk plus 1 equals to 1 is 0.7. And in question A, there are two cases when x2 equals to 1. The first is when x1 equals to 1 and x2 equals to 1. And the second case is when x1 equals to 0 and x2 equals to 1. In each case, we multiply the conditional probability by the preconditions, and the result is 0.4 times 0.2 plus 0.7 times 0.8, which equals to 0.64. And in question B, the calculation of x3 equals to 1 is the same as in question A. But we should first calculate the probability of x2 under various conditions to get the conditional probability of x3. The probability that x2 is equals to 0 can be obtained by using the method in question A. Therefore, the final result is 0.7 times 0.64 and plus 0.4 times 0.36, which equals to 0.592. In question C, we can use the formula of conditional probability to convert the probability that x1 equals to 0. Under the premise that x3 equals to 1, to the probability that x3 equals 1 under the condition that x1 equals to 0, and times the probability that x1 equals to 0. And divided by the probability that x3 equals to 1. The final answer is 0.52 times 0.592 and divided by 0.176. And in question D, we use the determination to find the probability that xn equals 0 when n tends to infinity, and we can use the determination to get the answer, and the answer should be 0.2 plus 0.2 times 3 divided by 7 and plus 0.8 times 3 divided by 7, and which the final answer is 3 divided by 7.